Starting in Chapter 3 here, we're going to take a look at a different way to measure angles called a radian measure. Radian measures are used in upper level mathematics. As you move forward, the degree measure will kind of play second fiddle to a radian measure. By definition, a radian is an angle with its vertex at the center of a circle that intercepts an arc on the circle equal to the length of the radius of the circle as a measure of 1 radian. In other words, a radian is based off of the radius of a circle and the ratio that the angle makes compared to the radius itself. The definition itself is not important for us right now. What we're going to learn how to do is convert angles from degrees to radians and radians to degrees. So theta is our angle, S is the length of our arc, and R is our radius. S, again, is the length of the intercepted arc. R is the radius of our circle. And theta is that angle then in radians. Okay, so theta equals S divided by R. S is the length of our intercepted arc, which is also sometimes referred to as a central angle. Length of the arc on the circle divided by the radius equals our angle in radians. As I mentioned already, radians are used to measure angles in higher level math classes. So we move on to pre-calculus and calculus. We'll see radians a lot more. To convert from a degree measure to a radian measure, we have what we call a unit multiplier here. That unit multiplier is pi times 180 degrees. So if we had 80 degrees, we'd multiply 80 degrees times pi over 180 and simplify by cross canceling and wind up with 4 pi over 9. On the flip side of that, we want to convert a radian measure to a degree measure. We multiply by the reciprocal, or another conversion of 180 degrees over pi. So those are our two conversions, pi over 180 and 180 over pi, depending on whether we're converting from degrees to radians or radians to degrees. Now we have 4 examples to get us started on how to convert from degree measure. You can see we have a degree symbol on each of these. I'm going to put this first one over 1 just to kind of illustrate how we can cross cancel. Our unit conversion then is to multiply by pi over 180 degrees. So when we simplify, rather than multiply straight across and then try and simplify it down, first thing I'm going to do is cross cancel. So the degree symbol is the first thing that goes. Once our angle no longer has a degree symbol, it's now considered to be a radian. And then 45 and 180 can both be divided by 45, and that gives us a radian measure of 1 pi over 4, or pi over 4. Noting that radians are typically written without a label, so if you see an angle written without a label, it's considered to be a radian measure. A couple more times here. Our unit conversion again is pi over 180. I'm going to put the negative 270 over 1. Show the same canceling. This time I'm going to knock off the 0 and the degree symbol, dividing by 10 and canceling the degrees. Then 27 and 18 can both be divided by 9, so we wind up with negative 3 pi over 2 as our radian measure for negative 270 degrees. Continuing on here, pi over 180 is my unit conversion. I'll put 330 over 1, cancel the zeros and the degrees. 33 and 18 can both be divided by 3, and we wind up with 11 pi over 6 as our radian measure. One more time. This time we have a decimal. So this one, only thing we would probably cancel is the degree symbol, numerator and denominator. After this, we probably simply go to the calculator and take, there we go, 2, well, let's see if it's going to work or not. Okay, 249.8 times pi is right above the division symbol here. No, it's not. Let's go back. It's right above the caret button. So times pi, and we'll divide that. Backtrack. So I'm going to delete that. Divided by 180. You can see that gets us about 4.36 radians. So if our degree measure was in decimals, we'll go ahead and put our radian measure in decimals as well. These are some common angles we'll see on our unit circle, which we'll talk about later. Oh, let's move on here. We have the opposite direction. We have radian measures to convert to degrees. Here we just flip the conversion factor over. So we multiply by 180 degrees over pi. To know that you're doing this correctly, two things are probably going to happen. Number one, the pi's are going to cancel each other out. And number two, we're going to insert the degree symbol. So I have 1 and 45, and that winds up getting us 405 degrees as our degree measure. A couple more times fairly quickly. 180 degrees divided by pi. We'll go ahead and cancel the pi labels. Pi, 6, and 180 can go down to 1 and 30. So we wind up negative 150 degrees. We'll keep going here. 180 degrees over pi. Go ahead and cancel the pi's. 1 and 1. 3 and 180 are 1 and 60. So we have 420 degrees. And we have a decimal here with our last one, so much like we did with our degrees to radians, we'll simply type this into our calculator, and we have 4.25 times 180 divided by pi. And that gets us 243.5 degrees. So a decimal we'll leave, start in decimal, we'll leave it as a decimal and go all the way through. The others we can simplify as we move. If no unit of angle measure is specified, then the angle is understood to be measured in radians. So I alluded to this when we started chapter 1, but bottom line here as we move forward, all of our angles written without this degree symbol up here are going to be considered to be radian measures. So labeling as we move forward becomes more and more important. So to give us an idea of what radians look like, we have a circle here, which we'll get in more detail later. I'm going to see if I can't put a coordinate plane on here. Here's my x-axis, and here is the y-axis. So as we start here, we know that this is 0 degrees. It's also 0 radians. It's also 360 degrees, or 2 pi radians. So all the way around the circle is 360 degrees, or 2 pi. If I go up here, I hope we all recognize this to be 0 or 90 degrees. This is the same thing as pi over, let's try that again. It's the same thing as pi over 2 radians. If I go over here, I have 180 degrees, which is pi radians. And if I go down to the bottom, didn't work out very well for us. But if I go down to the bottom, I have 3 pi. Oops, let's go back and do degree measure first. So our degree measure is 270 degrees. I kind of jumped the gun, but our radian measure is 3 pi over 2. If we cut the first quadrant in half, that should be somewhere around 45 degrees. 45 degrees is pi over 4 radians. And then we have kind of a family of graphs that go with that. If I cut the second quadrant in half, that's 135 degrees, which is 3 pi over 4. Easy way to get there, 45 times 3 is 135, so pi over 4 times 3 is 3 pi over 4. And we'll go to the third quadrant, I'd have 225 degrees. 225 degrees in quadrant number 4 is the same thing as 5 pi over 4. Again, same idea. 45 times 5 gets us 225. So 5 times pi over 4 gets me 5 pi over 4. And one more time here in quadrant number 4, we have 315 degrees. 315 degrees is the same thing as 7 pi over 4. So as we move through here, that's kind of our goal for the next day or two, is be able to equate certain degree and radian measure. If I go back to quadrant number 1, next commonly used angle we have is a 30-degree angle. 30 degrees is the same thing as pi over 6 radians. We'll have a family of those graphs as well. So if I go to quadrant 2, I have 150 degrees, which is the same thing as 5 pi over 6. The same idea applies. 30 times 5 is 150, so 5 times pi over 6 is 5 pi over 6. We'll have another angle here in quadrant 3. That angle will be 210 degrees, which is the same thing as 7 pi over 6. And one more here in quadrant number 4. We would have 330 degrees, which is the same thing as 11 pi over 6. So they're all multiples of 30. 30 times 7 gets me 210, so 7 times pi over 6 gets me 7 pi over 6. 30 times 11 gets me 330, so 11 times pi over 6 gets me 11 pi over 6. We would have one more set of angles here. That angle here in the first quadrant would be 60 degrees. And 60 degrees is the same thing as pi over 3 radians. And we'll have the same type of situation, a family of those graphs. I have 120 degrees, which is 2 pi over 3. 60 times 2 gets me 120, so 2 times pi over 3 gets me 2 pi over 3. And then I go down to quadrant 3 and have pretty much the same idea. I have a 240 degree angle, which is 4 pi over 3. And one more to plug in here. We have a 300 degree angle, which is 5 pi over 3. So those are some equivalent degree and measure, some common ones that we'll see over and over again. Again, we'll plug those in on the unit circle later on, but for right now, our goal is to simply recognize or equate those radian and degree measures. And I believe that covers section number 1.